Hello and welcome to the video. So in this video we will be discussing about deadlocks and deadlock handling methods. So this is the table of content. So in this presentation we will see about overview of deadlocks, deadlock prevention, deadlock avoidance, deadlock detection, deadlock recovery, deadlock avoidance versus deadlock detection, deadlock handling and operating system, and in the end we will see conclusion of the all important points. So these are the topics we will be covering in this video. We will be studying about overview of deadlocks, deadlock prevention, deadlock avoidance, deadlock detection, deadlock recovery, deadlock avoidance versus deadlock detection, deadlock handling and operating system, and in the end we will learn about all the important key points as a conclusion. So let's start this video. So first we will be understand what is a deadlock. So a deadlock is a situation where a process or a set of processes are blocked waiting for some other resources that is held by some other waiting processes. The following are the four conditions that must hold simultaneously for a deadlock to occur. Mutual exclusion. A resource can be used by only one process at a time. If another process requests for that resource, then the requesting process must be delayed until the resource has been released. Second condition is hold and wait. Some processes must be holding some resources in the non-shareable mode and at the same time must be waiting to acquire some more resources which are currently held by other processes in non-shareable mode. Third point for a deadlock is non-preemption. Resources granted to a process can be released back to a system only as a result of voluntary action of that process after the process has completed its task. Fourth condition that should occur simultaneously is circular wait. Deadlock processes are involved in a circular chain such that each process holds one or more resources being requested by next processes in the chain. So when these processes occur simultaneously, then a condition of deadlock occurs, which is properly illustrated in the diagram. Here we can see that process 1 and process 2 are on hold. So in the diagram we can see that process 1 is on hold because it needs a resource 1 from process 2, and in the same way the process 2 is again on a hold because it needs resource 2 from process 1. So this type of pattern followed by these two processes forms a deadlock condition, and to handle this condition we will be learning some of the algorithms. So now we will studying about importance of handling deadlocks. Why there is a need to handle these deadlocks condition. So first point is resource utilization. Deadlocks can lead to inefficient resource utilization. When resources are locked due to deadlocks, other processes or threads may be unable to access those resources, resulting in decreased system efficiency. For example, if a process holds a resource without releasing it, other processes that need that resource will be blocked, leading to the wastage of the resources. By resolving deadlocks, resources can be freed up and utilized optimally, improving resource utilization and overall system efficiency. So, next point is system stability. Deadlocks can cause system instability. When a deadlock occurs, processes or threads may become unresponsive or freeze, disrupting the normal operation of the system. By handling deadlocks effectively, you can ensure that system stability should be increased and maintaining the system's ability to function consistently and reliably. Next point is user experience. Deadlocks can negatively impact user experience. When deadlock occurs, applications or system may become slow, unresponsive, or non-functional, and no user wants that their application should become slow or unresponsive. So this leads to the frustration for user. So by handling deadlocks, you can maintain a smooth and responsive system, enhancing the user experience and satisfaction. Next point is system performance. Deadlocks can degrade system performance. When deadlocks happen, unnecessary delay occurs and resources are tied up without being effectively utilized. This can lead to decreased throughput, slower response time, and overall degraded performance. By effectively handling deadlocks, system performance can be improved, which results in better response time, increased throughput, and a more efficient operation. So, this will increase the system performance. Next point is data integrity. Deadlocks can pose a risk to data integrity. If a process holding a resource is terminated abruptly due to a deadlock, it may leave the data in an inconsistent state or lead to data corruption. For example, if a database transaction is interrupted due to a deadlock, it can result in incomplete or enormous update to the databases. By handling data of the database, these deadlocks and the data integrity of the system can be preserved, avoiding data corruption or loss and ensuring the accuracy and consistency of the data. Next point is reliability and availability. Deadlocks can cause system failures and affect the reliability and availability of the system. When deadlocks occurs, processes or threads may get stuck, preventing the completion of critical tasks and leading to system downtime. By effectively handling deadlocks, we can prevent system failures, improve system reliability, and ensure the availability of services, minimizing disruption and maximizing uptime of the processes. Next point is scalability. So now deadlocks can hinder scalability in systems that rely on concurrent processing. When deadlocks occurs, they can limit the ability to effectively utilize system resources and scale the system to handle increased workloads. By addressing these deadlocks, we can enable efficient utilization of resources, facilitate scalability, and ensure that the system can handle growing demands without sacrificing performance or stability. So this will lead to increased scalability of our system. Next point is compliance and security. So deadlocks can be exploited by malicious actors to disrupt or compromise a system. For example, a hacker may intentionally create a deadlock situation to cause a denial of service attack or gain unauthorized access to resources. By handling deadlocks, we can securize. So now we will study about the methods for handling deadlocks. So first method is deadlock prevention. The strategy of deadlock prevention is to design the system in such a way that the possibility of deadlock is excluded. The indirect methods prevent the occurrence of one of three necessary conditions of deadlocks, that is mutual exclusion, no preemption, and hold and wait. The direct method prevents the occurrence of circular wait. So first we will studying all three methods one by one. So first is mutual exclusion. Mutual exclusion is a necessary condition for a deadlock. It states that at least one resource must be non-shareable, meaning only one process can access it at a time. To prevent deadlocks related to mutual exclusion, the following approaches can be employed. First is resource splitting. Resource can be divided into smaller units that can be used concurrently by multiple processes. For example, a printer can be divided into multiple virtual printers. Second is spooling. Spooling involves using intermediate buffers to allow multiple processes to access a resource indirectly. For example, print jobs can be spooled to a disk before printing. So this is the example demonstrating spooling. Here input devices are connected through main memory to a disk and output devices are connecting to disk through disk from main memory output devices are connected. So this is spooling. Next is hold and wait. Hold and wait is another condition for deadlock. It implies that processes must request and hold resources while waiting for others, which can lead to resource wastage and potential deadlocks. To prevent deadlocks arising from hold and wait, the following strategies can be employed. Process declaration. Process should declare all the resources they need upfront before starting execution. This ensures that a process does not start executing until all required resources are available. Next is resource reservation. A process can request and reserve all the required resources before execution begins. This ensures that the process will have all necessary resources available when it starts. So now next method to prevent deadlock condition is Banker's algorithm. Banker's algorithm is based on the concept of resource allocation graph. A resource allocation graph is a directed graph where each node represents a process and each edge represents a resource. The state of the system is represented by the current allocation of resources between processes. For example, if the system have three processes, each of which is using two resources, the resource allocation graph would look like this. Processes A, B and C would be the nodes and the resources they are using would be the edges connecting them. The Banker's algorithm works by analyzing the state of the system and determining if it is in a safe state or at risk of entering a deadlock. So here's a brief description of how the Banker's algorithm works. So first is initialization. The system initializes the maximum resource allocation for each process, the available resources and the current allocation of resources to process. Next is resource request. When a process requests resources, the system checks if granting the request would result in an unsafe state, potentially leading to a deadlock. If the request can be granted without causing an unsafe state, the system temporarily allocates the resource. Now next is safety check. The system performs a safety check by simulating the allocation of resources for all pending requests, including the current request. It determines if this allocation would result in a safe state where all processes can complete their execution without a deadlock. If the state is safe, the request is granted, otherwise it is denied and the process must wait. Next is resource release. Once a process has finished using its allocation resource, it releases them back to the system, making them available for other process. So this is the Banker's algorithm and by using it we can avoid our deadlock. So next topic is deadlock avoidance. The deadlock avoidance algorithm works by proactively looking for potential deadlock situation before they occur. It does this by tracking the resource usage of each process and identifying conflicts that could potentially lead to a deadlock. If a potential deadlock is identified, the algorithm will take steps to solve the conflict, such as rolling back one of the processes or preemptively allocating resources to other processes. Two techniques are used to avoid a deadlock: process initial denial and resource allocation denial. Now we will be studying about advantages and disadvantages of deadlock avoidance. First, advantages. Not necessary to preempt and roll back processes. Second, less restrictive than deadlock prevention. Disadvantages. Future resource requirement must be known in advance. Processes can be blocked for long periods. Exist a fixed number of resources for allocation. Next is deadlock detection. Deadlock detection is used by employing an algorithm that tracks the circular waiting and kills one or more processes so that the deadlock is removed. The system state is examined periodically to determine if a set of processes is deadlocked. This technique does not limit resource access or restrict process action. Requested resources are granted to processes whenever possible. It never delays the process initiation and facilitates online handling. The disadvantages is the inherent preemptive losses. Next is deadlock ignorance. Deadlock ignorance. In the deadlock ignorance method, the operating system acts like the deadlock never occurs and completely ignores it even if the deadlock occurs. This method only applies if the deadlock occurs very rarely. The algorithm is very simple. It says that if the deadlock occurs, simply reboot the system and act like the deadlock never occurred. That's why the algorithm is called the ostrich algorithm. Advantages of deadlock ignorance. Ostrich algorithm is relatively easier to implement and is effective in most cases. It helps in avoiding the deadlock situation by ignoring the presence of deadlocks. Disadvantages of deadlock ignorance. Ostrich algorithm does not provide any information about the deadlock situation. It can lead to reduced performance of the system as the system may be blocked for a long time. It can lead to a resource leak as resources are not released when the system is blocked due to deadlock. Next is deadlock recovery. Deadlock recovery is a strategy used to resolve deadlocks in computer system. When a deadlock occurs, when two or more processes are waiting indefinitely for resources held by each other, the system enters a state of deadlock. Deadlock recovery technique aim to break this deadlock and allow the processes to resume their execution. Here is a brief overview of deadlock recovery strategies. Process termination. One approach to deadlock recovery is to terminate one or more processes involved in the deadlock. By selectively terminating processes, the resources held by these processes can be released, breaking the deadlock. However, care must be taken to ensure that the terminated process do not hold critical data or have a significant impact on the system's functionality. Next is resource preemption. In resource preemption, the system forcibly takes back resources from one or more processes to break the deadlock. The preempted resources are then located to other processes to resolve the deadlock. Preemption can be based on priority or other criteria, and the preempted processes may need to restart their execution once the deadlock is resolved. Rollback and restart. This approach involves rolling back the execution of processes to a previously known safe state and then restarting them from that point. The system keeps periodic checkpoints of processes states and can use these checkpoints to recover from deadlocks. By rolling back and restarting processes, the resource allocation leading to a deadlocks are eliminated, allowing the system to continue its operation. Killing and restarting. In this strategy, all processes in the system are terminated, and then the system restarts them. This effectively clears all existing resources allocation and breaks the deadlock. However, this approach can be disruptive and may result in the loss of unsaved data or the disruption of ongoing operations. So now we will see all of the important points that we have covered in this presentation one by one in this conclusion slide. So in this presentation we have explored various aspects of deadlock handling in computer system. We started with an overview of deadlock where we understand what is a deadlock and read four conditions that should occur simultaneously in order to make a deadlock condition, which is a state where two or more processes are unable to proceed because they are waiting for resources held by each other. We then see different deadlock handling techniques, beginning with deadlock prevention. Deadlock prevention involves designing the system in a way that eliminates at least one of the necessary conditions for deadlock to occur. We discussed approaches such as resource allocation graph, the banker's algorithm, and careful resource allocation to prevent deadlocks. Moving on, we examined deadlock detection, which involves periodically examine the resource allocation state to identify the presence of deadlocks. We explored techniques such as resource allocation graphs and cycle detection algorithm that help in detecting and resolving deadlocks once they are identified. Finally, we explored deadlock recovery, which focuses on breaking deadlocks and restoring system functionality. We discussed strategies such as process termination, resource preemption, rollback, and system restart to recover from deadlocks. So this is from my side, and thank you for the video.